Hello and welcome to the video with the solutions to the Math 20-2 Unit 3 unit exam. So first off, we have our one and only written response. Solve for side F and round your answer to the nearest tenth. Show all your work. And it's the showing your work part that has driven it to the written response instead of a simple numeric response. The triangle we are given has a 75-degree angle, no confirmed right angles, and that 75-degree angle is in between sides of length 13 and 15. So this is side angle side construction. We solve that with our cosine law. So let's fire up a new whiteboard. So with side angle side, what we are looking for is side F. So the equation in this case would be F squared equals D squared plus E squared minus 2DE cos of angle F. This uses every piece of information that we have. So F would therefore be the square root of this. And if we go back here, so side E is 13 centimeters and D is 15. I'll put in the square root later to make sure I have the correct amount of space. So this is our substitution, which we can now enter directly into our calculator. Notice that each term under the square root involves centimeters squared as the units. So the units are going to work out. So we have the square root of 15 squared plus 13 squared minus 2 times 15 times 13 times the cos of 75 degrees. Which works out to 17.1 centimeters when we go to the nearest tenth. Now notice just answering 17.1 does not involve showing all your work. So this 17.1 would not be considered a sufficient response on the test itself. So it is only acceptable here because we have the work on the whiteboard. So this work would have to be submitted to get full credit for this question. So in the following diagram, O is the center, the circle is a radius of 6.46. QR is 2.57 and RS is 4.06. We need the length of PQ. We also need angle QPR. So we are given the radius, so that gives us OR and PO. It also gives us PR because we could double it for our diameter. So we know QR, OP, we are asked for PQ. For that, we are going to need an angle. So how are we going to get our angle here? We have length QR, and we have RS. Now we know these angles at P and S match. They subtend the same arc of the circle, meaning they both terminate at Q and R. And since they are both mounted on the outside of the circle, these angles must be equal. Now PQR. So this one, the PR subtends the same as the angle at Q. So PQR. So both of these would cover the same arc from R to P on the bottom right of the circle, which means the angle at Q, PQR, has to be half the angle of POR. That makes that a 90-degree angle. So that makes triangle PQR a right-angled triangle. We have our hypotenuse. That is our diameter. We have length QR. That means length PQ we can get from the Pythagorean theorem. So it's the square root of our diameter squared minus QR squared. So to the nearest tenth, that's 12.7. And then angle QPR, we can actually get with just regular trig because this is a right angle. I'm going to do it with the inverse sine because that uses the two pieces of information we were given. The opposite there is the length of QR, which is 2.57. And the hypotenuse is 2 times 6.46. So this angle is 11.5 degrees. So this one we were able to do with Math 10C trigonometry. It was just a matter of working through the logic of this circle and the construction. Now here we need to find the measure of angle A to the nearest degree. This is direct substitution and manipulation. So it's just a matter of solving for A. So that would be the inverse sine of the sine of 51 times 35 divided by 28, which is 76 to the nearest degree. In this construction, the values of y, well, y is on a straight line, so that would add up to 180 degrees, but we have 68 on the other side, so angle y must be 180 minus 68, or 112. Angle z is part of a triangle, and we know that we have a 72 and a 68 in that triangle, so z must be 180 minus 72 minus 68. That gives us 40. And x is a corresponding angle because we have these red arrows telling us that's parallel. So that's the same 68 that we had down below. Now here, we need to find angle B. Given length A, length B, and angle A. So this is another application of the sine law. So this is the inverse sine of 15 divided by 22 times the sine of 19. So to the nearest whole degree are 12.82525393355. That rounds to 13. So number 8, we are given the 3 side lengths. What's angle A to the nearest tenth? So this is side, side, side. This is the cosine law, but we're going to have to do some manipulation. So if we have c squared is a squared plus b squared minus 2ab cos c, and was it angle? Oh, we're asked for angle A. So let's use the angle A version. A squared equals b squared plus c squared minus 2bc cosine A. So we have a squared minus b squared minus c squared is a negative 2bc cos A. So cos A, when we cancel out our negative and divide, we have b squared plus c squared minus a squared. So a is the inverse cos of b squared plus c squared minus a squared over 2bc. This is the algebra that we will be using. So we are going to have the inverse cos. We put extra brackets in our calculator for our numerator. B squared is 10 squared plus 12 squared minus 8 squared. I close the inner set of brackets, divide it by, and open another set of brackets, 2 times 10 times 12. Close our denominator brackets. And to the nearest tenth, that works out to 41.4. Now here, it's another application of the sine law. So we are given angle A, side A, and angle B, or we need to find angle B given that length. So that's the inverse sine of the sine of 29 times 9 divided by 12. To the nearest whole degree, that's 21. And the measure of each interior angle of a 6-sided polygon. So if we draw a 6-sided polygon, the interior angles are these in the corners. We could chop this into 6 triangles. The inner angles would be 360 degrees divided by 6, so that's 60. The angles in these corners of our triangles would be that 180 minus 60, which is 120, divide that by 2. So these are all 60. We make a hexagon with 6 equilateral triangles. So the interior angle is a 60 on the left plus a 60 on the right for 120. So this solves our Unit 3 unit exam.